Hello. Hopefully everybody can hear me. Sorry I'm a little late. Uh, so just make sure that everybody signs in. Um, there's the form I put in the chat, so you can sign in. I will also post this on the SoDA chat. Um, please sign in. There we go. Cool. All right. Um, Hopefully the stream goes pretty well. My internet's been kind of acting up a little bit, so let me know if the quality gets, terrible or something. Um, I will uh try to see what I can do to remedy that. Okay. So again, please sign in. The link is in the chat. It's this one, the forms.gle. And if you can please sign in, and again, if you're not a Sac State student, then just go ahead and put NA. And if you are, but you already graduated or whatever, you can put it in there anyway. I'm just going to use this so I can keep track of like who comes, how many students are coming, so I can give this information to the school, and maybe they can, maybe they like this sort of thing, and maybe there's something we can work out with the school to make this part of the curriculum, or something like that. I don't know. We'll see what happens. Okay, so the last time we stopped, I believe here at data types, after we did the case, different types of casing you can do with identifiers. So let's go back a couple slides and just go over the casing real quick. So again, with casing, this is, so Omar's asking, would we still fill out the form if we watch the recordings? Um, Good question. Probably not. Like if you just watch the recordings after, that's fine. I usually keep the sign in open until the end. Um, but if you can sign in right now, that'd be great. If you're watching this after the fact, then the sign in will be closed, so it won't really matter. Um, okay. So yeah, so casing. So again, these casing styles that you see here, the camel case, which is supposed to be where, if you have two words and you're conjugating them together or just, putting them together, you usually use the underscore to act as a space. Okay, so this is how C and C++ actually does it. Or at least back in the day, they kind of want you to use camel casing in C++ now. I don't do that because it's just weird. All the APIs in C and C++ are camel cased. Especially like the STL libraries, they're camel cased. So I just stick camel casing. That's my preference again, but it depends on the company you work for. Okay, all of these things I'm talking about is in the general, in the general umbrella. But at the end of the day, whatever your company tells you to do, they're going to have their own coding style and guidelines, and you just have to do what they tell you, regardless of what your preferences are. When you're working on your own projects, you can have your own preferences, and that's totally fine. But once you work for a company, your preferences don't really matter. You can ask, hey, can we use tabs over spaces, stuff like that. But if they say, nah, here we use spaces, then you just gotta go with what they tell you. Okay? And this is not because they don't care about your opinions. It's more like they kind of want to establish a uniformity. Basically, when you write code, um, it's supposed to look, at least in theory, it's supposed to look as if one developer did the whole thing. That's kind of like how it's supposed to be, right? So nobody's doing some crazy stuff. Everything just looks uniform, like if one developer had done the whole thing. So that's kind of like the idea there. Okay, so again, these are casings that's supported by JavaScript. So either of these three works, okay? But again, this is going to heavily depend on the company that you work for. Okay. And again, we went over this. As you can see, this is incredibly hard to read if everything is just lowercase. This is terrible, okay? Here is a lot better. You can actually read. Here is an example of an identifier with the first letter of every subsequent word, okay, being uppercase after the first word. So you can see that here, this is lowercase, but every other word that follows, including words that we would probably see as insignificant, like is and of and an, those are still uppercase. Now, the only exception to that is whenever we're dealing with variables in JavaScript that are technically objects. For example, a class will eventually become like an actual object, right? So some creature, that's why S is capitalized. And we're going to see this with React when we create functions or React functions, like components. They're going to be uppercase, even though technically they're just variables, but we will be uppercasing them because the context in which we're using the variable is actually going to be an object. So that's why we do that. Okay. All right. So let's move on to data types. Now, you might be thinking, if you know a little bit of JavaScript, you don't have to define a data type. And you're right, because JavaScript is what's called a dynamically typed language. So examples of dynamically typed languages is like Python. That one's dynamically typed. Obviously, you have JavaScript and stuff like that. So these languages are dynamically typed. So what does that mean? It means that when you create a variable, you don't have to specify a data type. So this means that by just looking at a variable, there's no way for you to really tell what type it is. And so in some ways, that's actually pretty cool. Oh, Hermon has a good point. PHP, yes, that's another language that's dynamically typed. So when you create a variable, okay, in the way JavaScript works, in other dynamically typed languages, is that it's just a container. Okay, so you can think of like a cooking pot, right? You have a container, that's your variable, and you can put a fork in there. You could put food, you could put water, you can put whatever you want. And if you had a big enough pot, you could probably even put a car in there, right? If you had a big enough pot. So you can just hold whatever you want. Versus if it's statically typed, it means that the containers or the variables that we build, they can only contain certain types. For example, if you had a cauldron, that's supposed to hold, let's say, vegetables after you clean them. They have holes in the bottom. You couldn't hold a liquid inside of a cauldron because there's holes, right? So automatically your container is rejecting certain types of objects that you can put inside of this particular container. And so that's where we talk about data types. So JavaScript, dynamically typed, yes, but even dynamically typed languages still have data types. Under the hood, there are still data types. So this way we can distinguish between the different types of data. So the data types, again, this concept is pinnacle to computer science. So we need to understand this. And this basically just defines the types of data that we're going to be operating on. And that's basically it. So these are the data types that JavaScript supports. We have numbers, we have strings, we have booleans, we have objects, and we have functions, okay? Now, this type of is an operator. So given any value, type, or variable, if you run type of on it, it'll tell you what the type is as a string. So in this case, if I say, what is type of 0? It would return a number. If I say type of, and then the string hello there, for example, I will get string because I created it as a string, and so on and so forth. Now, the concept of an array, okay, the concept of an array in languages like C++ and Java, okay, they are different. They're not objects. They are arrays. They have their own type because in those languages, they have very specific functions. Like, for example, an array in C++ or in Java, you cannot change their lengths. It's not possible. They are fixed length, okay? However, when we talk about arrays in JavaScript, that's the interesting thing. The arrays in JavaScript aren't really arrays. Okay, it's a data structure. Okay, people call them arrays. That's fine, but they're not really arrays. They act more like a list or a vector from C++. That is, you can continuously add things to your array that has that functionality. Okay, which is why when we run the type of on an array, we always get back object, because there is no definition of an array. The way arrays in JavaScript work, they act more like vectors. So they act like arrays, but they have other functionality on top of it. You're going to find out that JavaScript does this a lot for certain data structures. Okay. So here what we call the primitive types, right? The most, simple data types that we can play around with. These are the primitive types. We have number, we have string, we have Boolean, and then we have a data type called undefined, which by the word is undefined. It means it's like null in Java or in C++. However, JavaScript, there's a distinction between undefined and null. So here are some examples of a complex type. A function is a complex type. Okay. And here's an example of 2 ways to declare a function. Now again, we have a whole section of functions, so don't worry if this looks a little confusing. We will touch on this. So here's one way to write a function in JavaScript. All right, and this is another way to write a function in JavaScript using arrow notation. And again, in other languages, you'd be like, this is not an object, this is an array. But again, in JavaScript, the arrays act more like vectors. And so this the data structure underneath the hood is an object, not a primitive array. And then here's an example of a JSON object, which stands for JavaScript object notation, hence the word object. And this is what an object looks like. It's a sequence of tuples, right? So we have key value pairs here, the key name, and then a string here, optionally, key here with an array, right? So we'll talk about JSON more extensively later, but here's just some examples of some complex types. Okay, cool. So here's an activity. So some of you guys were asking before, hey, I would like to have like some kind of like homework or something I can do to practice. Well, there you go. Here's an activity. So I will do some of this stuff. I'm not going to do exactly what this activity is going to do, but I'm going to do some of this stuff, but in a different example, and then you guys can do this on your own. And again, the solutions to this are at the very end of the slides. Okay. So let's open up VS Code. Okay. And again, if any of you guys are having issues with VS Code for whatever reason, post it in the Discord chat, and then somebody I can answer, anybody else that beats me to the punch. Okay, so the first step here, display name and age using variables. Okay, so before we go into that, let's just build variables and then display them. So in the last session, we kind of already did that, right? We built some variables when we're talking about literal values. So the reason why we call these literals is because, well, you can literally see their values, 2 and 4, right? You can literally see them. This is not a literal value because I have no idea what X and Y are. Now, if I look up here, yeah, I can totally tell. But you can imagine that if I only had this, right? If I just said var and then result equals X plus Y, and all you saw was that, that's not a literal value because X and Y can take any type, right? They could be numbers or they could be strings. That's the thing I don't like about dynamically typed languages. Like there's no way of telling, right? So and the other thing too is the way you name variables. This is where naming variables comes into play. If you poorly name your variables like X and Y, like those are terrible variable names, unless it's a mathematical equation, then that's fine. But X and Y, I have no idea what any of this stuff means. Okay. So again, that's why we call these a variable, right, and not a literal, because we have no idea of knowing. But in this context, yeah, X is 2, Y is 4, you can pretty much compute in your head, okay, result is going to be 6. And so in JavaScript, if we want to, display something to the console, okay, then we just use console.log. And if you, this basically just displays something to the terminal or the console. And so I can bring up my console here. So the way I can do that is I can just go to view, or terminal, I say new terminal, and then there we go. I can see it there. I can say view. If I close this, I should be able to bring it up. View. Terminal right here even gives you a shortcut. Control plus backtick. So the backtick is the button that's to the left of your number 1 on the keyboard. So you just click on that. Okay, or you can use the shortcut. Control and then backtick. That's the one I use, and then it brings it up. Okay, so that's how you can hide it and bring it back very quickly like that. All right, and to run the code, we're using Node. Again, that's a prerequisite. You need to have Node installed. So you just type in Node, and then you feed it the file. So you can see here the file is code.js. So I feed it code.js, and I run it, and there we go, and I get 6. So I printed out 6. Okay, not too bad. Okay, so that takes care of A. B, compute the sum of 2 numbers. Okay, so I accidentally already showed you how to do that, so I'm going to skip over B. C, compute the following formula. Okay, cool. So here, we have some values that we have to use. So let's say, what's a formula we could use? So let's say you were trying to do a calculator that could solve, a very specific formula. Let's say you had the formula y equals mx plus b, and you knew what m, x, and b were. Okay, so let's do that. So we say var m is equal to, let's say, 12. So it has a very steep slope. Var x, so at some point in the number line, let's say -1. Right, and then var b is equal to, again, this is where you start off on the y-axis. So let's say we'll start off at 0. So we're going through the origin. Okay, so then what is y? So you can say var y is equal to m times x plus b. All right, cool, not that bad. Console.log. We can say, we can either just print out y by just feeding it the variable like so, and running that gives us -12. Okay, pretty simple. Or we can do some other stuff. I'll leave the other stuff for later. Okay, if you guys have any questions about that, let me know. Again, if you have some experience with programming, that should be review. If you're new, please ask questions. All right, strings. This is where things are going to get a little weird. So with strings, in computer science, strings are just characters that are like strung together. That's why we call them strings. So you can imagine that you had like, what are those birthday signs? Yeah, right here. Boom, perfect. This is a perfect example. So you can imagine that these letters right here are just characters, okay? And then this string kind of connects them, okay? So you can see that they're strung together. So this sequence of characters here, happy, are strung together, okay? And it creates this string. That's what in computer science, that's what we're seeing this. This is just a string. So this is an example of 2 different strings, happy and then birthday, and each one is just a character. Now the characters could be, basically anything, really. Characters can be anything. They can be letters, they can be numbers, they can be symbols, okay? So, so that's very important. In JavaScript, there are a number of different ways of creating strings. So we can use a single quote, okay? So you can use single quotes. That's what this symbol right here is, single quotes. We can use double quotes, and we can use a backtick. So the backtick is actually something that's part of ES6 called template literals. And we'll talk about that later. But just know that there are 3 ways to create a string, and each one has its own advantage over the other one. Okay, so here I'm creating some string literals with my name, Kevin Pacheco. And you'll notice I'm using a single tick. Okay, so that's pretty basic. Okay, so there you go. And yeah, so these are just strings using just a single character, a single tick, and then I'm just logging them all here. All right, it's pretty simple, right? Now here's an example of writing the string literals, but now using double quotes. Okay, using double quotes. Okay, so there's an example of that right there. So these two are the same, except they're using different symbols to construct the string, but the data type is still the same. They're both strings. Okay, so single versus double quote. When should you use one over the other? It matters, sorta. So single double quotes are treated the same as far as the type. They're going to be strings. The difference here happens when you're escaping certain characters. For example, you want to escape the quotes. So let's say you wanted to have a quote, you know, like I'm Batman, said Batman, you know, you want to put that in quotes. Well, if you use double quotes, then you have to escape them, and I'll show you an example of that. Okay, that might be a pain in the butt. But if you use single quotes, well, then you don't have to escape them. And again, I'm going to show you an example of that. And so that's why, you know, this stuff is kind of like, you know, it depends on what you're trying to do, right? But for the most part, it's all going to be treated the same. Now, where it starts to actually matter is when you look at the JSON specification. The specification mandates that you use double quotes. So if you were an engineer and you were trying to build an API that supported JSON, okay, and you were building the decoder for it, you cannot, I mean, you could, but you're not supposed to have single quotes as a first-class citizen when determining if a sequence of characters will be considered a string. It has to be a double quote. Okay, now JavaScript, again, supports single and double quotes. But when you're talking about JSON as just the transporter of data, the specification mandates, and I have the proof right here, you can just click on this link and you go read the specification, it supports double quotes. It has to support double quotes, okay? If you decide to support single quotes, that's fine, but you have to support double quotes. So depending on the API that you're using, generally, if you're using some RESTful service from Facebook or Instagram, you'll notice that all the strings that come back to you will be in double quotes. Okay, they're not going to be in single quotes. They're always going to be in double quotes. Okay, so what does this mean? If you have no idea what sequence of characters you should use, single, double quotes, always default to double quotes. Unless you have a good reason to use single quotes, just use double quotes, okay? Now, you're going to find out as you learn JavaScript and you go to some other tutorials and you find some code on you know, on Stack Overflow or whatever. A lot of people, you're going to see sometimes using single quotes, sometimes using double quotes, and yada, yada, yada. I think just for the sake of consistency, just use double quotes, because in other languages, the way you create strings is double quotes. You cannot create them using single quotes because single quotes is reserved for a char type or a character type, which is a single character of a string, okay? So if you have no idea what to use, always use double quotes, okay? It's not wrong, okay? It's just, it's more consistent with other languages as well. Cool. So let's talk about some string operations that are pretty popular to do on strings, okay? So these are the following string operations that I think you should know right off the bat. And the first one is, how do you uppercase a string? So let's say you had a specific word, like let's say the first name, but you wanted the first name to always be uppercase for whatever reason. Then you can easily just do wherever the string's at, whether it's a variable or a string literal, and you just say dot to uppercase, and it'll always return a new string that's all uppercase. Okay, you can do the same thing with a to lower. Okay, you can apply a dot to lower on it, and it'll return a new string with all lowercase. These operations do not manipulate the original string. They always create a new string, and that's something you're going to have to keep in mind. Now, string.length will return the number of characters that it's in the string. Okay, so the word hello has HELL O, right? So hello, so that's 5 characters. So this will return 5. And then you have something called concatenation, which is using the plus sign. So a string plus another string is a new string with those two strings put together. And then it's not going to add a space in between. You would have to be in charge of adding a space, okay? And I have here in red something very, very important. Strings are immutable. This means that they cannot be changed. Once you declare a string, okay, once it gets placed in RAM, you cannot change that string. It is fixed. Okay, that's what we mean by immutable. Now, that's not to say that the variable that you assign the string, you cannot change it. Yes, you can. That's just a container. But the actual data that is the string that's in memory is you cannot change it. It's what we call immutable. Okay, so we'll talk more about that. So here's some examples of taking a string literal and then just adding a 2 uppercase to it. Okay, now again, you can replace this with a variable if it had a string, and you can do it too. Okay, so here's my name, first name, and my last name. Again, I'm using single quotes to create the string. Okay, I'm just showing you that it doesn't matter. And then I'm just 2 uppercasing it, 2 lowercasing, and that's it. And then here I'm concatenating them. So I'm taking this, my first name, and I'm adding to that a space, because again, when you concatenate 2 strings, it doesn't add a space for you. You would need to add a space if that's what you need to do. So I add a space, and then with this new string, I add another string, which is my last name. Okay? So effectively, this variable full name will contain the string that has Kevin space Pachecl. Okay, that's what full name would have. And then, for some reason, let's say you wanted to know, okay, what's the length of the full name? Well, you can just take the full name, because this is a string, and just say dot length, and that'll count how many characters there are in this entire string sequence. Okay, and that's about it. And then I can do in my console log, I can concatenate everything. And I can say display full name plus space has space plus length plus space characters. So I can create a whole sentence. Full name has length characters. So once this displays to the console, it should say Kevin Pacheco has, and then however many characters, right? Okay, so here's activity 2. So combine your city name with your state abbreviation. So example, Sacramento, comma, California. Okay, and use a comma and a space to format it. So create a variable that has your city name, okay, as a string, and then create another variable that has the state as an abbreviation as a string, and then display it using a comma and a space, how you normally see it on a website. Oh, Sacramento, comma, California, for example, right? So whenever you go on Google, it usually tells you where you're at. If you scroll all the way to the bottom, it'll say from blah, right? So an example of that would be like if you go to, let's say, google.com, usually at the very bottom, it'll say here, you know, once you actually make a search, we can say like pizza. If we scroll all the way down, it says right here, look at that. It has my zip code, and it says Sacramento, comma, California. So I'm showing you an example of something that you would have to do in the real world. Somebody had to write this code in order to get this to work. So I'm asking you something very, very basic, but you could look at this website. This website's doing that, right? It's a very simple example, but all this, you know, it comes together, right? It's all one thing. And then lastly, we say use the length string operation to get the number of characters in your city's name. Okay, so let's do some code here. Delete that. So I'm saying instead of doing the city and name stuff, I'm just going to do my name. So let's say let's do first name is equal, let's say Bob var last name. We'll say that equal to Dylan. Okay, so you can imagine how you could replace this to do the city and state abbreviations. Okay, and then let's say you wanted to do You know, sometimes when you go to a website that's very formal or whatever, it has your last name followed by your first name with a comma. So let's do that. So we'll call this full name reversed is equal to we'll say last name plus comma space plus first name. Okay, so I wanted to have my last name and then a comma and a space and then my first name. So that's how I do it. See that? So this I am concatenating last name and then first name with a comma and a space. Okay, then we just display to the console.log, full name reversed. We'll clear this node code.js, and it says Dylan, comma, space Bob. Beautiful, very simple. Okay, now let's say you want to know how many how long is this person's name with the comma and the space. Like how long is this characters? How many characters is this string? So you say console.log full name reversed space contains space and then full name reverse dot length. You can even see right here. The cool thing about having something like VS Code or some kind of text editor that can give you code hints, it tells you returns the length of a string. How cool is that? It's even helping you out, giving some pointers. So this returns the length of a string. Okay, cool. So contains that many characters. Many characters. Cool. So now we run this. So it says Bob, comma Dylan contains 10 many characters. Well, I'll just say 10 characters. I'm not an English major, okay? Contains 10 characters. There we go. Bada bing, bada boom. Done. Nice. Now, what if you wanted to know how many characters first name contain? Well, we can just put first name contains, and then change this to first name characters. So it says Bob contains 3 characters. There you go. It counted for you. Nice. So you can imagine if you needed to count how many characters were in a specific string, how you could automate this. You could use .length to do that. So again, I'll leave activity 2 for you to do on your own time. And if you get stuck, there's solutions at the very end, but do try and do it on your own. If you have any questions, you're having some kind of problems, that's what the Discord chat's for. All right, cool. Now we're getting to some a little bit more complicated stuff. Functions. So functions is just a block of statements. And based off the first set of slides that we did yesterday, we know what statements are. They're just instructions for the computer, for your program. So a block of statements executed when invoked. So you just put pieces of code together and you just call it a function. Functions may return a result, a computed result, that's possible. And you may use parameters, right? So here are some examples of some functions, okay, at a high level. Let's just look at it from far away. So you'll notice that these are all using the keyword function. So that's interesting. We have this. So again, observe everything that you're seeing. We have the keyword function. We have something here, my function. I wonder if that's important. You have some parentheses, interesting, curly braces. And in here, I'm saying that your statements go there. By statements, again, this is code that can be executed by your program, by the computer. Okay, so here's an example of a function. And notice that it's no longer called my function. This one's called add. And you'll notice that we have 2 options here. We have number 1 and number 2. So this is what we call parameters, right? Number 1, comma, number 2. And again, this is different from other languages, is that like a statically typed language, there's no data types here. I am using the variable to convey to the developer, whoever's going to use my function, that this is number 1, this is number 2. That is, that these are numbers and not strings or functions or objects. And this particular function, add, is very descriptive. It adds. It adds what? I'm assuming num1 and num2. And what's cool about this function returns the arithmetic addition of num1 and num2 by just using the plus sign. Okay, pretty cool. And in this function, we have is positive. Well, that's interesting, right? Is positive. So whenever you have the word is something, that's usually a Boolean statement. You know, is it free? Is it hot outside? Is it cold? You know, whatever. So whenever you have a is with a function or anything like that, you should always think true or false. Either it is or it isn't. So in this case, is positive, and then I have a value here. So you should automatically think, okay, so this function must do something with a number that's going to check whether or not it's positive or not. So if it's positive, we would assume that this function would return true. Otherwise, will return false, right? So again, by being descriptive in your function naming, a developer can just look at it and be like, okay, I can kind of get what's being done here. Okay, that's why it's very, very important that when you name things appropriately, and you give it some kind of context as to what the function is going to actually do. What is its job? In this case, this function is just going to check if a particular value is positive. Okay, so here's an example. So positive numbers is anything that's greater than 0. So we return value greater than 0. This is called a comparison operator, which is a Boolean operator, which allows it to compare two different types of values, and then check to see, you know, if the following thing is true. For example, is value greater than 0? Right? If that's true, then we return true. If not, we return false. Okay, so now let's look at the anatomy of a function. So I call this the function signature, but I have to say something about this. If you are in an interview and somebody asks you, what's the difference between a function or method signature and a function and method header? The difference is that a signature, again, okay, a signature also contains the return type. Now, the thing about JavaScript is that there are no types. So there is technically no way of knowing if a function will actually return something. So then it is then impossible to know what the type of the return value will be, because in JavaScript, there is no way of telling. So that, again, this is what you get with dynamically typed languages. Okay. So I'm very hesitant of fully just saying, yeah, this is a function signature, because you're technically missing, okay, so what's the return type? See, you don't know. It's unless I tell you, there's no way for you to know. In other languages, however, like let's say, Java, it would say something like integer or num, or string or char, whatever, my function, or even void. Void is the return type. It means it just doesn't return anything. We don't have that here. So again, I'm just saying this just in case you ever get asked, let's say you're talking to a recruiter and they say, hey, what's the difference between a function signature and a function header? You should be like, well, in statically typed languages, a function signature is the header with the return type. In dynamically typed languages, you generally don't have a return type indicated. And that's it. And they'd be like, okay, wow, this guy knows. Or this girl knows, whatever, this person knows, whatever. Okay, so this entire thing now here is an example, okay, of a function header with the parameters. And again, I put in parentheses here signature because if this is a statically typed language, the return type would either be here or somewhere. There would be an indication of the return type. In JavaScript, there is not, so which is why I kind of put in parentheses, okay? And I even make a note here, a function / method signature is supposed to also contain the return type. In JavaScript, however, there is no way to explicitly state this, but in TypeScript, we can. So when we touch TypeScript down the road, you're going to see the differences between TypeScript and JavaScript, and why after I teach you JavaScript, you should do yourself the favor and learn TypeScript as soon as possible. Okay, so now this, for sure, 100% is the function header. So the function header contains this part right here, and parameters or no parameters. It really depends, right? Some functions have parameters, some of them don't. But this part right here is called the function header. And then here we have the keyword. Again, this is very specific to JavaScript. We have a keyword here called function to tell the computer, hey, this is a function. This right here, the name of the function is an identifier. And we already talked about identifiers, 5 slides ago, of how you can create an identifier and what are valid identifiers. Okay, so we know that identifiers cannot start with a number. We may have symbols, but the symbols must be limited to $signs and underscores. Okay, you can have characters such as letters and numbers, and that's it. So your function, because it's also an identifier, this part right here, the function name is an identifier, it must follow those rules. So if you need a refresher on what valid identifiers there are, go read the previous slides. It was like 5 slides ago. And in here is the parameter list. Okay, they're contained here in parentheses. Okay, parameter 1, parameter 2, parameter 3. You could also have no parameters. That's also a possibility. You don't have to have parameters. But if your function does have some arguments that you need to have passed in, we call those parameters in this context. And then the function definition is basically all of your statements. This is what defines your function. You can think of this as the definition to a word. In a dictionary, you found the word, well, that's great. And then, usually there's a sentence or a paragraph or whatever that explains the definition of that particular word. Well, we found the function, that's great. Now, the definition of what this function does is all the code that's here. This defines that function. That's why we call it the function definition or the method definition, whatever. So functions and methods are always going to be contained within curly braces. This contains them. This way, we know where the function begins and where it ends. Okay? Now, if your function returns a value, like it computes something and returns that, then we use the return keyword. So there's a new keyword we just learned, return. And you can return whatever. Okay, whatever is supported by JavaScript, you can return it. And then the entire thing is called the function implementation or the method implementation. Okay, so if you need to know all these keywords, there you go. Now, this is called function invocation. It's how you, quote unquote, call a function or call a method. It's called invocation. You invoke something. Okay, so if you want to have the proper terminology, it's called invocation or invoking, not calling. Although technically people use that, but it's invoking or invocation. So here's an example of a function that takes no parameters, has no parameters. Okay, and we invoke it like this. We just have the identifier and then just the parentheses. So it looks very much like the header, and that's about it. And then we end it with a semicolon. So this will invoke this function. Not too bad. Now here's a function that takes one parameter called param1. Okay? And in the invocation, we do not call this a parameter. We call this an argument. So when you're actually passing the data to the function, we call that an argument, not a parameter. The parameter is here. In the context of your function or methods, these are called parameters. In this context, when you're doing the actual invocation, this data that you pass in are called arguments. Okay? Does that make sense? The difference between a parameter and an argument? It depends on the context. Arguments are passed through when you're invoking a function or a method. Parameters are in the context when you're actually at the function implementation, the function definition. Then you call them parameters. Okay, so those are the two contexts, invocation, and we're just looking at the function definition or the implementation. Okay? Okay, so let's look at functions again. So again, function header, you have an identifier. We can also call them name, label, or ID, whatever you want to call it, right? But it's just the identifier. And then you have a comma delimited named parameters. Okay, again, that's optional. Okay, and they're usually enclosed with parentheses. Okay, and then you have the function definition, which is just a sequence of statements contained by curly braces. That's your code. And then you have the function invocation when you actually, want to run or execute that particular function. So the function invocation contains the identifier. So which function do you actually want to execute? You follow by the parentheses and then containing arguments. So an example here is you have some identifier followed by the parentheses and then any arguments that you need to pass to that particular function, and you terminate it using a semicolon. So the semicolon says, okay, we're done with this line of code, we're done. And again, ends with a semicolon. Okay, so now we're off to activity 3. Very good. So activity 3A, create a function that adds 3 numbers and returns the result. Okay, so let's create a simple function here. Remember, delete all this, clear this. So let's create a function. I'm gonna say function. Instead of add, I'm going to subtract. So I'm just gonna do something that's not on the slides. So I'm not doing the slides for you, okay? So I'm gonna call this sub for subtract, okay? And subtract, let's say my function only takes 2 numbers. You take a number A and a B. So subtract is going to take A and then subtract from it B. And we want to return this result. So there's a couple of ways we can do this. One, we can create what's called an intermediate variable. So var, we can say result is equal to A minus B. Okay, and then we can just say return result. So this is what we call an intermediate variable. Now the reason why we call it that is because technically I don't need it. I can literally just copy that, paste it right there, and just return A minus B. That's totally valid. However, sometimes you're going to realize that this code, whatever that code may be, or formula, whatever you have there, can sometimes be quite complicated. And it might be kind of hard to understand by just looking at it. So using an intermediate variable sometimes can help make things more legible. Yes, it's extra code that you're writing, but it will make your code more legible, okay? So again, there's 2 ways of doing this. One, using an intermediate variable, or not. Again, this is on a case-by-case basis, depending on the complexity of your code, and then also depends on the company you work for. They might say, we prefer legibility over smaller code size. And then at that point, well, intermediate variables, there you go. You're probably going to have to use them. Cool, so I can say var result is equal to sub, and then I pass in the arguments for A. So the argument for A, I'll say, let's say 10, and I want to subtract 5. So 10 minus 5 should be 5. So the result, I would hope, is 5. So console.log result. All right, so let's run this code, node code.js. 5. Okay, cool. I subtracted 2 numbers. The activity said 3 numbers. But I did 2, so, that gives you an option to try that out. All right, now it says create a function that takes a radius and returns the area of a circle. Okay, cool. So let's do something like that. So I'll leave this code up there so you guys can read that. So what I'm going to do instead is let me remove this real quick because I don't want that to execute. I'm going to write a function that, given any number, will just double it. Will always double it. Okay. So function, I'll call it double it. Okay. So we'll take in some number. I'll call it number. And it always returns that number, but doubled, whatever it may be. Okay. So I'm going to say return number times 2. Right? I doubled it. Okay, so I'll say var result is equal to double it, the number 10. Okay, so I'm just going to, Well, I guess I can just delete all this. Let me just delete all this. Don't need that anymore. Okay, so I created a function called double it. I pass in a number, and I take that number and I multiply it by 2, and that's effectively doubling it. And again, there is this sequence here. There's no reason why I put number first and then the times 2. Okay, you could totally do 2 times number. Okay, I just wrote number times 2, but you can do 2 times number. Doesn't matter. Okay, and say console now.log, and hopefully my result is 20 because the argument I provided for number is 10. So say node code.js, and I got 20, so I doubled it. Nice. Now let's write a function where you can put in your bank statement and doubles your money. Now that would be cool, right? Yeah, that's never happening, right? But that would be cool. Yeah, so there we go. We doubled it. Not too bad. All right, C, create a function that returns the average of 2 numbers. Okay, so we gotta do some division. Okay. So I will do the average of 3 numbers. Okay, I'm gonna do the average of 3 numbers because 2 numbers, that's part of the assignment. I'm gonna do 3 numbers. Okay, and then you do it on your own. So function, call this AVG of 3 numbers. Okay, average of 3 numbers. Okay, so we have A, B, C. So how do you calculate the average of 3 numbers? Right, that's the next question. Is how do you calculate the average of 3 numbers? How do you calculate the average of n numbers, right? Or of n whatever. So you're supposed to add them, right? You add them, and then you divide by however many there are. Okay. At least, I'm a math minor, but I sometimes forget, right? So hopefully I said that correctly, and you guys can correct me if I'm wrong, okay? All right. So we said we need to add them and then divide by how many there are, and that should give us the average. Okay. So return A plus B plus C, right? And then divide it by how many there are. Well, A, B, C, that's 3, so I divide by 3. And this should give me the average of 3 numbers, correct? Anybody have a problem with the code that I wrote here? This makes logical sense, right? Or no? Well, we'll see. Hopefully you guys are paying attention. All right. All right. So you say var result is equal to average of 3 numbers. All right. So the average of 5 and 5 and 5 should be 5. Everybody saying yes, sir? Makes sense to me. So the average of 3 numbers, 5, 5, 5, right? Well, if all the numbers are the same, you should get the same number back, right? Okay. Console.log result node code.js. Whoa, 11.666. What the heck? That's not the average of 5, 5, and 5. Because 5 plus 5 plus 5 is 15. 15 divided by 3 is 5. What the heck happened? Right? Average of 3 numbers, A plus B plus C, divided by 3. Well, what's the problem? Well, what's wrong with this formula? Jim Bob is correct. PEMDAS. So computers are not so dumb. They have built into them instructions for PEMDAS. So when you're doing arithmetic operations, please keep in mind PEMDAS. Okay, that is, we have parentheses. So parentheses. We have exponents, which is like these. In our case, we have the double star for JavaScript. That's how we do exponents. We have the M, which is just a star for multiplying. We have the D for division. That is the /. And then we have the A for add. that is the plus sign. And then we have the sub for subtraction, which is the minus sign. Okay, so if you read this and you say, okay, a plus b plus c, then divide by 3, well, you're wrong, because PEMDAS says which has precedence. Addition is down here, multiplication has higher precedence, so actually, or division has higher precedence than addition, so actually, this would happen first. It would ignore this and go to here. So 5 divided by 3 is like 1.66, and then we're adding to that 5 and 5, which is 11.66, whatever. Oh, dang. Right? So there's something wrong here. So it did division before it did the additions. Okay, if I wanted addition to have a higher precedence, how do I fix this using PEMDAS? Anybody have a possible solution for this bug? Right? We finally wrote our first bug. Are you guys proud of yourselves? We wrote our first bug, right? The first of many. Sad face, right? So that's our first bug. So how do we fix this logical bug? Using our PEMDAS there. How do we fix it? Emmanuel Silva says parentheses. Hermot said parentheses 5 plus 5 plus 5. It definitely won't be the last bug. Yes, that is very true. So Hermot says do, okay, now he fixed it to a plus b plus, I was going to make fun of him. I was going to delete this and say, oh, okay, so 5 plus 5 plus 5, right? Obviously not. So we want to make sure that we have the a, the plus, the b, plus the c. So what's the solution for this then? Whatever you want to have a higher precedence when we're talking about arithmetic operations, PEMDAS and stuff, use this to figure out how you can give something extra precedence. So I just moved up the addition from this bottom row to the top because I surrounded it with parentheses. So this entire thing will then happen first, then we'll get divided. So let's see if that fixes our problem here. So we're going to run the code again, and now we get 5. Beautiful. Right? Bug solved. Great. All right. Cool. So we did the average of 3 numbers. Now you figure out how to do the average of 2 numbers, and hopefully you don't have a logical bug. All right. D, create a function that returns the sum of the lengths of 2 strings. Ooh. Notice how I worded that one. Create a function that returns the sum of the lengths of 2 strings. I will leave that as an exercise for the reader. Again, the answers are at the very end of the slides, the solutions. Again, try to do this on your own. Use the Discord, ask questions, okay? So I'm going to leave that one. That's an interesting one, okay? All right. Now, on Monday, I said that I was going to, I wanted to keep it to like an hour, but it's up to you guys. If you, an hour and a half would probably be better, because right now we're at an hour. It's 7 o'clock. But if you guys want to go to 7:30, I'll go to 7:30. So whatever you guys think. Should we do an hour and a half or keep it at 1 hour? What do you guys think? Let me know. I will look at the comments and I will go. Keep going. And again, if you have to leave, by all means, you're free to leave, and then you can watch the VOD later. If you have work or anything else. So what do you guys think? Should we keep going? Nobody's answering on the chat, so maybe we should call it, I guess. Could do an hour and 15 too. Yeah, it's totally possible. Going on the chat here. Maybe keep it to an hour for today just in case. Okay. Dan, this is a great spot to leave at. We have JSON that's coming up next. Um, Emmanuel says works for me to keep going. Okay, because it's up to you guys. I don't want to burn you guys out. If you guys think an hour is good enough or an hour and a half, whichever way. Hugh says keep going. Okay, all right. So I really want to cover JSON, so let's keep going. We'll do it to an hour and a half. So at 7:30, we'll call it a day. And then you can always come back and watch the 30 minutes, before you go to sleep or something like that. 1.5 hours is fine. Okay, cool. All right, so let's go for an hour and a half. And Sam is absolutely right. JSON is very important and is very powerful. And if you get a job in today's market, not knowing JSON is like a handicap. You cannot do that to yourself. You have to understand JSON. So today, right now, let's talk about JSON. Okay. So JSON, what does it stand for? Well, we kind of already talked about this earlier. I kind of talked about what it stood for. So JSON just stands for JavaScript object notation. Okay. So that's what the JS just means JavaScript. O is object, N is for notation. So, somebody might ask you that. Hey, what does JSON stand for? Oh, JavaScript object notation. Okay, give them the job, right? No, I wish it was that easy. So, what is JSON composed of? JSON is just composed of a bunch of properties. That's really it. Just a bunch of properties. You can call these attributes. Maybe you can even describe them as adjectives, data, behaviors, okay, that are just functions that describe the object. These are just things that describe the object. Nothing more, nothing less. That's basically it. The JSON is made up of primitive and complex value types. Okay, so remember, we already talked about primitive types, right? Earlier in the slides, we talked about primitive types. That is strings, numbers, booleans, that kind of thing. Those are primitive types, arrays. And even the complex types. So the complex types would not be a primitive type. It'd be more of a complex type. So array would be your complex type. Okay. And then we have this idea called tuples. So the way you construct your JSON is using tuples, key value pairs. Okay. So this is what the anatomy of a JSON looks like. So we have usually create a variable. You contain it inside of a variable, right? So we have var, and then again, your variable, which is again, follows the naming convention for an identifier. So you have to have a valid identifier. So there's that. So again, this is not part of the JSON. This is just creating a variable. This is the JSON right here. So the JSON has these curly braces like that, and then you have a key value pair. So your key could be, whatever, but it's also an identifier, okay, in this context. And then use a colon to separate the key from the value. And in this example, the value is just a string that has the word value in it. That's it. Okay, and then you end it with a semicolon. Okay, so what's really cool is now I can use something called the dot operator. So I can say my variable identifier, which contains my JSON. I can then use the dot and then whatever key to get the value. So in this case, the key just so happens to be called key. So identifier.key gives me the value of key, which is just value. I know, very confusing, but we have examples coming up. All right, so again, you create a variable like always, var result, var a, var b, whatever we've been using so far, okay? Now, here's the definition for the JSON. Again, so the curly braces will contain the object, okay? The definition of your JSON object, okay? You end the JSON object using a semicolon. Okay, now technically JavaScript, you don't need semicolons, but I am going to stress that you should always use semicolons when you're ending your statements, okay? Now you'll notice here the properties are created in a key value pair fashion. They are separated by a colon symbol. That's the two dots that you see like that, okay? The key is an identifier, so it follows the same rules with naming, with one exception, that is keys as strings explicitly. Okay, we'll talk about that. So if you need to know again what are valid identifiers, go back to the slide where we talked about identifiers, and then look at the rules that you must follow in order to be a valid identifier in JavaScript. And then here we go. So here, notice the use of double quotes over single quotes for, in this example, a string. For the most part, it's okay to use single quotes. However, it's a good practice to prefer double to ensure JSON specification compliance. Because I told you already that the JSON specification says it must use double quotes. Although JavaScript supports single quotes, it's better that if you have no idea what to use, just always revert to double quotes, and then you'll be okay. Most APIs will support single quotes, but they are not obligated to do so. This becomes an issue when transporting JSON over the internet, which is why you use JSON.stringify will ensure double quotes is used, but it's good practice. Okay, so if you ever have any doubts, use double quotes. If you use single quotes and you're transporting the data over the internet, when you use JSON.stringify, it will always replace the single quotes with the double quotes. All right, here we go. To access a property's value, we use the dot notation. That is, you have your identifier, right? Whatever your variable is called. You use the dot and then whatever the key is. Okay, this is read. This right here, you read it as identifier dot key. So you literally say the period, you call it dot, right? Okay, to access a property's value, we can also use bracket notation. So that's identifier with the square bracket, the key in double quotes or single quotes. Remember, it's just a string. Okay, and then you end the bracket. Okay, so we can do that. And I put a little note here. We use this alternative form when we do not know the key's identifier explicitly. That is, if you have a JSON object, you can actually loop over it. You could actually loop over it. And we can do this. Okay? So if you don't know what the property is, what the key is, you can use something like this to dynamically, extract the data out. And the other time you will use it is in the following. Whenever you, for some reason, I really don't understand why people do this, but if you wanted to use a hyphen, right, for the identifier, again, remember what I said, valid identifiers can only have the symbols $sign and underscore. But somebody, for some reason, wanted a hyphen. Fine. So how can JSON support this? Well, if this is the case, then notice that the key now is forced to be a string. Now that we have a string, we can use any character that a string supports. So now your identifier can have numbers in the beginning. It can have all kinds of symbols, okay? However, if you go this route, in order for you to extract the property's value, you can only use bracket notation, okay? So that's a sacrifice that you give up, right? A sacrifice that you actually have to make if you want to use illegal characters in your identifier. Okay, so this is only true for JSON. Okay, you cannot do this anywhere else. So hyphens are illegal tokens in identifiers. However, the exception is if you use a string as a key. In fact, you can use any token as long as it's a legal character for a string. Okay. Here, when using strings as keys, you can only use bracket notation unless the string is a valid identifier. Then you can use a dot notation as well. So in this example, it should be abundantly clear using the dot notation is not possible. Because of that hyphen, you cannot do it. Okay, cool. So now we have an activity. So we can activity here says create a JSON object that contains your first name and last name, then display each property to the console using both dot and bracket notation. So I will do this activity with you. Well, we'll do a couple of things with the JSON. Okay. Let me close that. First, we'll say var, and we'll say artist, right? Call it whatever you want, right? So we have artist. So now in here, create a JSON object of your favorite artist. Okay. So we'll say for the artist, I'm going to say name. Call this Bob Dylan. Okay. Comma. And we'll say, you know, what's the genre of music they're in? American folk. Okay. Now you'll notice that when you have multiple key value pairs, you separate them using a comma. Okay. If I take it away, right, you're going to see, whoa, JavaScript's freaking out. Like, what the heck is this? Yo, I expected that. Oh, you can click on this. It says view problem. Whoa, it's even pointing at it. That's cool, right? That's very cool. So go ahead and put a comma. And then all the problems are solved, right? Okay, cool. So we have the artist, which is the name here, Bob Dylan, genre, American folk. Not bad. Let's put the year they started producing music. Let's say year of music production, whatever. Let's say we put a number here, right? So I want to show you an example of putting a number here. So we'll say 1961. Let's say. Okay. I don't know the actual year he started making music. I know it's somewhere in the 60s. Okay. Or was it the 50s? No, it has to be the 50s because, yeah, it had to be the 50s. All right, whatever. We'll just say 1961. Who cares? All right, cool. All right, not bad. Not bad, not bad, not bad. All right, so let's say I say, okay, now let's display this information and put it to the console, print it out. Okay, so we say console.log artist. Now, again, there are two ways to do this. The dot notation, bracket notation. So let's start off with the dot notation. Dot, there's a beautiful thing about using a visual editor is that it gives you some hints. Look at that, right? So if I hover over genre, right here, I'm using the arrow keys on my keyboard. I can go like this, okay? If I hover over genre, look at right here, it even tells you, yo, the property genre even tells you the type. It's a string. That's true, because I use double quotes. It tells you that name is also a string. How about that? And when I hover over year of production, it says it's a number. It's a little crammed, but you can see that it's a number. Yo, that's pretty cool. Okay, so let's do the name first. Console, we'll do console.log artist.genre, console.log artist.year of music production. Okay, now let's log this to the console. So let's run this. So node code.js. There you go. Bob Dylan, American folk. And notice the difference here. The coloring is different. So that's the cool thing about when you're working with Node and it prints to the console, it'll actually color it based off the data types. So if it's a string, it's like this regular gray color. And if it's a number or a Boolean, it'll actually be colored like this yellow color. So it's highlighted. Okay. So let's add another one here. Artist, let's say is alive. Yeah, that's true. Okay, so is alive is true. So let's take a look at what a Boolean value looks like. So artist dot is alive. So let's run this again. And there you go. So you see true is highlighted. It's got this highlighted color. Okay. All right, awesome. Okay, so these are examples of using the dot notation. Okay, cool. Now let's do the same thing. Let's achieve the same effect using bracket notation. So I'm going to start here at the top. So the following will be examples of using the bracket notation. Okay, so again, we want to display the name. So console.log, we'll say artist, And then we start with the square bracket, hit that, and then we have to use a string. Okay, for now, we use a string. Boom. As soon as I do my double quotes, okay, let's remove that. Do it again, double quotes. Look, it's helping me out. It's helping me out. Isn't that cool about using an editor? It helps you out. It's like, yo, do you want genre, is a live name, or year of production? That's pretty cool, right? Okay. Can I use single quotes? Absolutely. There you go. Single quotes. Genre is a live name, year of production, because it's a string. As long as you have a string, it'll do that for you. What about the backticks? Yes, if I use the backticks, again, that is an example of a string. Again, the backticks have very special powers, okay, called literals. What's it called? What was it called? Why am I forgetting the name? Anyways, it has special functionality, the backticks, which we'll talk about later, okay? That's very, very cool, okay? But yeah, as long as you have a string, you can put that in there. Okay, so I want the name. Boom. Very good. Okay, there you go. Console.log. Let's do genre now. So we have artist, bracket, a string. I'm going to use a single quotes just to make it very clear. Genre. Okay, console.log, artist, bracket, year of music. I'm going to use the backticks. Oops. Year of music, console.log, artist. I'll go back to double quotes, and then is alive. Okay, and I'll run this. Let me clear this console. Node, code.js. And you'll notice that, again, they're repeating because I have this here as well. But you notice that they both have the exact same output. There's no difference. Okay? Okay, so again, examples using the dot notation, examples using the bracket notation. Very cool. Okay, so I'm going to delete all this. Now, here's the extra cool thing, the feature that you get when you use bracket notation. So I'm going to say call this var property. Okay, I didn't have to be property. In fact, I'm not going to call it property. I'm going to call it tuna. But know that this is supposed to be the property. I'm going to call it tuna just so you know that the naming has zero effect. It doesn't mean anything. It's just a variable. So I'm going to say tuna is equal to, now I want to assign the string based off the property, the actual key. So let's say tuna is going to have name. Okay, it just has name. Okay. Now, with this variable, I want to be able to extract the key. Not the key. I will use this as a substitute for the key in order for me to extract the variable, the value. So let's do that. So how do we do that? So let's just print it out, console.log. Artist, use bracket notation. I will pass tuna in here. And there we go. That's interesting. Because remember, tuna is just a variable that holds a string. What's the string? Well, in this case, it's name. So this is effectively the same as if I had just put name in here. Okay. So I'm going to run this, node, code.js. Look at that, it says Bob Dylan. Now I can change this to be, say, genre. And I can run this again, and I get American folk. I can change this to be is alive. And it's true. I can change this to year of music production. And I get 1961. Okay. So I will change this name to something a little bit more more suitable. We'll just call this property name. Okay. So again, look at the way I'm able to do this with bracket notation. So because the brackets just accept a string, a variable can contain a string, so I can go ahead and put that in here, and it's effectively the same thing. So that's one of the things that you get with bracket notation that you cannot do with dot property. So the dot property, this is not possible. Okay. It is not possible for me to do this with dot property, but with bracket notation, I totally can. Okay, so I want to get rid of this console.log just to make this abundantly clear of what's actually happening. So I have this property name. So I'm going to create another variable called property value. I want this variable to contain the value, okay, of the lookup of property name inside of my JSON object. So I'm going to say is equal to artist at property name. So this is going to give me, hopefully, when I do this, when I look it up, I will get the property value. Okay, so let's log console.log property value. Okay, again, this is like an intermediate variable because I don't really need this. I can just put that right here, but I want to make this more legible. So hopefully this makes more sense. So node code.js, again, I get 1961 because here year of music production is a valid property name. So I'll type in name here because we have a property or a key called name. So I'll run that and I get Bob Dylan. Do genre. There you go, American folk. So property value is now assigned American folk, and I'm just logging out the property value. Is this making sense? Is any of this not making sense or confused? Anybody have any questions? Please let me know. Now, what happens if I put something in here, if I try to look up a specific property name that doesn't exist? Like, let's say albums. Albums is not a valid property name. So I wonder what would happen. So Jim Bob says, I have a question. Is JSON a true object that can be instantiated and contain methods, or is it closer to like a dictionary in Python? That's a great question. And it's actually, the answer is it's actually both. You can actually instantiate this, and it also acts like a dictionary. So yes, to both. I can say new artist, and yeah, that's, although it may not have the effect that you're probably thinking, but it is possible to say new object. It's possible to do that, but it's not the same as making a copy. It just has its own reference. The this keyword would actually change depending on the context. That's stuff that we're going to talk about later, but yes, JSON objects is basically a dictionary. And if you know what dictionaries are, that type of data structure, then yeah, you basically are almost to fully understanding JSON objects. JSON is just dictionary, but it has extra stuff that we can do with it. Okay. But yeah, basically, yeah, 100%. Internally, it's just a hash table. That's basically all it is. But with a lot of other advanced techniques. So one of the weird things about objects, for example, is if you have an array, you can actually convert an array into a hash table, which is very weird. But yeah, you can totally do that. But if it makes it easier to understand JSON objects, just think of it as a dictionary or a hash table. 100%. Yes, 100%. That's why you can do stuff like this. I bet you when you saw this syntax, you immediately thought, yo, that looks like a dictionary from Python. Absolutely. Yes, yes, because they're sharing the same type of data structure. Yeah, 100%. These are just the keys, and this is just the act of looking it up. You're looking it up in the dictionary. All right. So what happens if we try to look something up that doesn't exist? What happens? Like albums. Albums is not in our dictionary, as Jim asked. Yeah, it's not here. So let's run this. What happens? We get undefined. Look at that. It's kind of grayed out and stuff like that. You get undefined. Okay, it didn't crash, so that's cool, but we got undefined. Now again, undefined is not the same as null. Those are two different things. So we have undefined. Could you do this with dot notation? Could you try to look up a property that doesn't exist using dot notation? And the answer is yes, you can. So I'm going to erase all this. So imagine I have var property value is equal to, and I'm trying to do this with dot notation. So I say artist dot, and I say albums. Okay. Now notice I'm not getting any error messages here. I'm absolutely not getting any error messages. But one thing you'll notice when I hover over albums, it just says any. Because JavaScript's not the interpreter here is not able to figure out ahead of time what the heck you're talking about. So I would say console.log property value. In other languages, if you try to do this, for example, it would crash. In JavaScript, it doesn't. We just get undefined. It doesn't know. Okay, it doesn't know. So it's undefined because by definition, albums is a property that has not been defined in our JSON object. Okay. However, we could define it. So here, this is my literal. This is my literal. Okay. This is my JSON literal because you can see the literal properties and values there. But here's the beautiful thing about objects. It's a double-edged sword. I can take my artist, I can say albums, I am creating a new property here, and I'm setting that equal to something. So I'll just call this albums for now. Now when I run this, it is totally defined. Now I don't get undefined, I get albums, or whatever it is that I put here. So that's the very interesting about JSON objects. You can do stuff like that. Okay? So I think that little bit of code that we wrote should basically take care of you being able to write these activities on your own. So activity B says write a function that takes the object made in part A, so you have to read this part, and returns the first and last name properties concatenated with the space in the middle, display it. Okay, so you should be able to do these by now based off what we did today and the examples that I showed you. So you have basically 4 activities to do on your own. And again, if you have any problems, go ahead and use the Discord to ask some questions. Please use the Discord to ask questions. Okay, use that to ask questions. And yeah, okay. So if you have any problems, ask questions, and somebody, either me, Corbin, Victoria, or anybody else that probably already did it and solved that problem can help you out. All right. Cool. So with that, I will call it a day. Oh, so yeah. So tomorrow, or was it Friday? We will talk about arrays. Arrays, very, very beautiful stuff. Okay, so I will see you guys on Friday, and we'll probably do another hour and a half on Friday, and we'll talk about arrays there. All right. So thank you, everybody. Again, ask questions on the Discord. Please ask questions. And with that, I will see you guys on Friday again at 6 o'clock. All right. Bye, guys.